So we're looking at question 1218, longest arithmetic subsequence of a given difference. It's a medium question, and let's start reading over it. Given an integer array and an integer, return the length of the longest subsequence in an array, which is an arithmetic sequence, such that the difference between the adjacent elements in the subsequence equals the difference. A subsequence is a sequence that can be derived from the array by deleting some or no elements without changing the order of the remaining elements. Okay, let's look at the example. So we're given an input array with which is a list with the 1, 2, 3, and 4, and the difference is 1. That's because 1 on its own is a subsequence of the whole list, so it's always going to at least be 1. Then 2 minus the adjacent element, which is 1, would be 1, and minus the difference should be equal to the adjacent element, which is also 1, and same goes with 3 and 4. So 1, 2, 3, and 4 are a subsequence of the whole list. For example 2, we have the array 1, 3, 5, and 7. We're looking for a difference of 1. In this case, like I mentioned before, 1 on its own is a subsequence of the whole array, 3 on its own is a subsequence, 5 on its own, and 7 on its own. So the output is going to be at least 1, but let's see if why it's only 1 and not 3 or 4 or 2. In this case, 3 minus 1 is not equal to the difference. 5 minus 1 is not equal to the difference. 7 minus 1 is not equal to the difference. 5 minus 3 is not equal to the difference. 7 minus 3 is not equal to the difference. And then 5 minus 7 is not equal to the difference. Another way to do that would just be to check if 1 plus the difference is in the array after what you're currently looking at. In this case, it would just be 1 because, like I mentioned, the single element on its own is at least one value, 1 being the subsequence of the list. We're given another array, 1, 5, 7, 8, 5, 3, 4, 2, and 1. The difference is negative 2, so in this case we have to go in a descending order. So 1 minus negative 2, or 1 plus negative 2 in this case, would be negative 1, which I don't see in the rest of this list. 5 plus negative 2 in this case would be 3, and so you look at 5 and 3 that exists. So we know that 5 and 3 are a subsequence. Then you look at 7, you see 7 and 8 doesn't work, 7 and 5 work, right? So 7 plus negative 2 is equal to 5. And then we know that, then we look at 8 again and we see that 8 minus 2, which is not in this. Then we look at 5, 5 minus 2 is 3, and we know that 3 is a subsequence, so this 5 and 3 are again a subsequence. 3 and 4 don't work, 3 and 2 don't work, 3 and 1 work, so we know that 3 and 1 are subsequences. And in return, we also know that 5, 3, and 1 are subsequences, but we also know that 7, 5, 3, and 1 are subsequences. 4 and 2 work, so 4 and 2 are subsequence, 2 and 1 are not subsequence. So we know that the 7, 5, 3, and 1 are subsequences because that's the longest order that we can go in that has a negative 2 difference. So the output is 4, and like they said, the subsequence is 7, 5, 3, and 1. Okay, let's go into the explanation on how to solve this question and then actually solve the question. Okay, let's look at the explanation for question 1218, longest arithmetic subsequence of given difference. We're given two different values, the array, which is 1, 2, 3, and 4, and the difference, which is equal to 1. I've created three different values here to track what we're doing. In this case, max value will be the largest subsequence that we've calculated so far. The dictionary will be all the different values that have come before and their subsequence count, right? So let's say we were at 2. The subsequence count for 2 would be stored in the dictionary as key 2, and the value being the count of the subsequence. The count will be starting off with 1 because that's going to be the current count for that specific value. We know that the specific value, like let's say 1, will always have a subsequence count of 1 being itself. So that's going to be the largest possible at all times. Unless, of course, we don't have anything in a list. And in that case, then the max value would just return 0, and then there's nothing else to calculate. So these are 3 different values we will be using to calculate. Now, we are going to go and loop through this array just once and compare if the current index value is in a dictionary, and then of course do some computation based off of it. In our case, when we start off with the value 1 at index 0, we know that count is equal to 1, and then we check if 1 minus the difference, so 0, is in a dictionary. In our case, it's not, and the dictionary is empty. So we just update the dictionary with the current count. So our dictionary value is going to go up to 1 key and the value 1 because the current count was at 1. Now we also want to update the max value. In our case, our max value started off with 0, but we want to compare it to the count for the dictionary at the current value. So we compare the max value at 0 to the dictionary key 1, right? These two values, and we see that the value is 1, being the larger value. So we update our max value to 1. Next, we go to the next value, which is 2, and update our count to be 1 again. We check and see if 2 minus the difference, in this case 2 minus 1, is equal to 1, and we check if that is in the dictionary. It is in the dictionary, so we want to update the count that we currently have to be the current count plus the value in the dictionary for the difference that we just calculated, which is 1. So we do the count plus the key 1 value, which is 1. So 1 plus 1. And so count becomes 2. And then we compare count 2 with the max value. We first put the value inside of the dictionary. And then we notice that 2 is greater than the current max value. So we update the max value with what we have. Next, we go to the next value, which is 3, and we update our count. So in this case, as you noticed, our count here gets updated, and so does the index that we're currently looking at. Once we do that, again, we check if the difference between the current value, which is 3, and the difference that we're given, so 3 minus 1, is in the dictionary. In our case, 3 minus 1, which is 2, is inside of the dictionary as a key, so we append that value to the count. So we do 1 plus the value at that specific key, which is 2, and we do 1 plus 2, which is 3. So our count becomes 3 now. And then you update the dictionary with the count that you had currently generated. So our dictionary at key 3 is going to be equal to 3. Last, we want to compare the max value with the value in the dictionary. So max value, which is 2, to this value in there. And we notice that 3 is larger, so we update our max value to be 3. And the last item that we'll be looking at would be the last index in this array we're given, and the value is 4. So now we do the same thing. We do 4 minus the difference, which is 1, and 4 minus 1, and we get 3, and we check if 3 exists in the dictionary. We see that 3 does exist in the dictionary, and so we add the value for key to our count, and that becomes 4. Now, once we're done with that, we just add this count value inside of our dictionary with the current value we're looking at as a key, and so it's 4, and 4 being the value again. Then we compare the max value with the value in the dictionary, and we notice that 4 is larger, so our max value becomes 4. And that's it. And then we just return the max value since there's nothing else we're looking at in this array, and so we output 4. Seems pretty easy. Let's go into the coding part of this problem. Okay, so let's go into writing the solution to this problem. I mentioned that we have a max value, which we're going to initialize with a 0, and we also have a dictionary, which is going to be empty. Count is something that we will be updating as we loop through the list. So we can initialize count inside of the list. We're just going to loop through the array. So for this is us looping into the array, and then we initialize our count, which becomes 1. And then we check if the count, if the array value that we're looking at, so if the value we're currently looking at minus the difference that we're given is in the dictionary. This is just checking if something like 2 or 3 or 4 is inside of a dictionary, or sorry, that minus the difference is inside of the dictionary, or 3 minus the differences in the dictionary. In our case, if we're looking at the first index, there's nothing in there. But once we do that, we have to update our count, right? So we do count plus equals to the dictionary value at the array minus the difference. So if that value did exist, then we update it with the value at that key. And once we're done with that, we just update the current value we're looking at, so dictionary at array. So we add that to the dictionary, but we initialize it with the count that we're currently looking at, or we have currently calculated. Lastly, we just want to update our max value. So max value is equal to the max of the max value and the dictionary at the array. What we just added in the dictionary, we will be using that in here to check if it's bigger than the current max value that we have. And that's it. And you just return the max value at the end, and that's it. I'll submit it as well. There we go.